Hi, this video illustrates the capabilities of Euresys' frame grabber cards when it comes to synchronizing the camera, sensors, and the lighting controller. This video is about acquisition from line scan or 1D cameras. When the object to be inspected is large, moving, or presents itself as an infinite web, it may be suitable to acquire the image line by line using a so-called line scan camera. When using a line scan camera, the frame grabber puts together the individual one-line images coming from the camera and rebuilds a 2D image in the host computer memory. As the individual lines of the image are acquired one by one, the challenge is to perfectly synchronize the camera line rate with the movement of the object or the movement of the camera in order to avoid image distortion. This is usually done by using an incremental motion encoder. An incremental motion encoder, either rotary or linear, is able to measure the angle of rotation or the position of an object. An incremental encoder will have its output toggle when the object rotates at a given angle or moves at a given distance. Euresys GrabLink and CoaxLink cards have GPIO input lines dedicated to the connection of motion encoders. They are then able to synchronize the camera line rate with the movement of the object to be inspected. When the objects move faster, the acquisition line rate of the camera increases. When the objects slow down, the acquisition line rate of the camera decreases. In the simplest operation mode, the frame grabber will request one line from the camera for each pulse received from the motion encoder. So if, for instance, the motion encoder generates one pulse every 100 microns, we say the encoder pitch is 100 microns, the camera will acquire one line when the object moves 100 microns. While keeping constant resolution, this mode is not very flexible, as you have to change the encoder as soon as you want to adjust the resolution of the acquisition. For that purpose, the Euresys GrabLink and CoaxLink cards incorporate rate converters, a set of devices able to convert the rate or resolution of the encoder. They allow the camera to acquire lines at any programmable resolution, lower or higher than the resolution of the motion encoder. Technically, the rate converter is able to multiply or divide the frequency of the signal coming from the motion encoder. This gives the designer incredible freedom and flexibility during the development of the system. To show you how it works, let's go back to our application where our motion encoder pitch is 100 microns. If we program the rate converter with a 1:2 conversion ratio, it's a division of the encoder's signal frequency by 2, we're going to acquire 2 times less lines, that is one line every 200 microns. If we program the rate converter with a 2:1 conversion ratio, it's a multiplication of the encoder's signal frequency by 2. We are going to acquire 2 times more lines, that is one line every 50 microns. We can even program the rate converter with a 1:1.27 conversion ratio. It's a division of the encoder's signal frequency by 1.27. We are going to acquire one line every 127 microns. With the rate converter, it is now possible to calibrate the system and choose the ratio that gives us perfectly square pixels. In addition, the board is able to decode A/B phase signals coming from quadrature motion encoders in order to know in which direction, forward or backward, the part is moving. When using such an encoder, the card can be instructed to acquire lines only when the object is moving forward or only when the object is moving backward. A feature called backward motion cancellation stops the acquisition when backward motion is detected. The acquisition automatically resumes when the motion is again in the forward direction at the exact place where the acquisition was interrupted. Euresys frame grabbers support continuous web scanning to inspect infinite, continuously moving surfaces without losing a single line, and discrete object scanning to acquire the image of objects moving in front of the camera. Let's see how to synchronize the beginning of the acquisition. We will use a trigger that we call Start of Scan trigger to start the acquisition when the part is in position. Hardware triggers, electrical signals, are connected to the board's GPIO input lines. This can be a presence or proximity detector or a signal from a motion control card. After it is started, the acquisition can continue indefinitely. For example, in this web inspection application where a plastic film is inspected, the inspection virtually never stops. Alternatively, the acquisition can continue for a programmable number of lines. This is used to acquire the image of objects of a known length. Or it continues until an end trigger is received. That's, for example, the case in this postal sorting machine, where the envelopes scanned are of a variable length. If the sensor cannot be put right in front of the camera, an optional trigger delay is available to postpone the beginning of the acquisition for a programmable number of lines. Euresys frame grabbers include numerous functions that simplify the overall design of vision systems or machines. For more information, please check our website at www.euresys.com and do not hesitate to contact us. Thanks for watching.